Good day, everyone. We are the Group 7, and we're going to discuss the Lesson 8 Transducers. So, transducers is a device which transforms a non-electrical physical quantity, such as temperature, sound, or light, into an electrical signal, such as voltage, current, and capacity. So, the transducers plays a crucial role in measurement, control, and automation systems, enabling the monitoring and manipulation of physical phenomena through electrical means. So, for transducers, we can ask that why is this important? Well, in modern systems, whether it's for measuring something or controlling a process, we need to work with electrical signals because they're easy to process, analyze, and transmit. Without transducers, we couldn't bridge the gap between the physical world and electronic systems. So, also, transducers is the form of the backbone of modern sensing and control technologies. So next, we have the two parts of transducers. First, we have the sensing element. So the sensing element is often called as the sensor. So this is the part that directly interacts with the physical quantity we want to measure. So for example, if we're measuring temperature, the sensing element detects changes in temperature and responds by reducing something measurable, like a voltage or resistance change. So for example, ang thermocouple. So it generates a small voltage when it senses temperature differences. Or let's say a photodiode which reacts to light by generating a current. So ang sensing element is like mura siya heart of the transducer because it determines how accurately and sensitively the device can detect the physical quantity. So for the second part, we have the transduction element. So ang transduction element convert the sensor output to suitable electrical form. So after the sensor has done its job, it's pick up the physical signal and given us an output. But that output isn't always in a form you can use directly. That's where the transduction element steps in. Its job is to take the sensor's response and convert it into a proper electrical signal. So this often involves amplifying or conditioning the signal so it's easier to process. So for example, in a strain gauge, the mechanical strain causes a change in resistance, which the transduction element converts into a readable electrical signal. So similar sa photodiode, the tiny current it generates is often turned into a proportional voltage to make it more practical for use in electronics. So if we put together the sensing and transduction elements make up a transducer, allowing us to measure, monitor, and control physical quantities in all kinds of applications, whether it's in industrial, automation, medical devices, or environmental monitoring. Transducers are absolutely vital. They're the unsung heroes that let us interact with the physical world in a meaningful electronic way.
So, the following factors are to be considered while selecting a transducer for further applications. Sensitivity. So, the transducer must be sensitive enough to produce detectable output. Operating range. The transducer should maintain the range requirements and have a good resolution over its entire range. The rating of the transducer should be sufficient so that it does not break down while working its specified operating range. Accuracy. So, a high degree of accuracy is assured if the transducer does not require frequent calibration and has small value for repeatability. It may be emphasized that in most industrial applications, repeatability is considerably more important than absolute accuracy. Cross sensitivity. So, cross sensitivity is a further factor to be taken into account when measuring mechanical quantities. There are situations where the actual quantity measured is in one plane and the transducer is subjected to variations in another plane. Errors. The error produced by transducer should be as low as possible. The operating principle. So, the transducers are many times selected based on the operating principle used by them. So, the operating principle used may be resistive, inductive, capacitive, optoelectronic, and piezoelectric, and etc. So, transient and frequency response. The transducer should meet the desired time domain specifications like peak overshot, rise time, setting time, and small dynamic error. It should ideally have a flat frequency response curve. In practice, however, there will be cutoff frequencies and higher cutoff frequencies should be high to have a wide bandwidth.
Okay, I'll now continue explaining the remaining factors we consider when selecting a transducer. Starting with loading effects. So the transducer should have a high input impedance and low output impedance to avoid loading effects. So when we measure a system, the transducer interacts with it. So loading effects occur when this interaction alters the system's behavior, potentially affecting accuracy. So, para ma-minimize ni siya, ang transducer dapat na siya high input impedance and low output impedance. So, ang kaning high input impedance, i-ensure niya nga ang transducer daw kay mo draw og minimal energy from the system being measured para ma-preserve iyang natural state. Then, ang low output impedance, i-ensure niya that the signal is transmitted efficiently to the next stage, such as a processor or display, without losses. Then, next is environmental compatibility. So, it should be assured that the transducer selected to work under specified environmental conditions maintains its input-output relationship and does not break down. So, transducers are often used in nagkalain-laing environments from industrial plants to outdoor settings. So, in the environmental factors like kanang temperature, humidity, dust, or vibrations kay maka-affect na siya sa performance sa transducers. For instance, kanang transducer nga gidesign siya for a high temperature furnace, dapat mo resist siya og heat and maintain accurate readings. Then similarly, ang transducer nga ma-expose sa moisture must be sealed to prevent damage. So selecting a transducer compatible with its operating environment ensures that it functions reliably under specific conditions. Then another factor when selecting a transducer is insensitivity to unwanted signals. So the transducers should be minimally sensitive to unwanted signals and highly sensitive to desired signals. So in real-world applications, transducers are often exposed to noise or interference, which can distort measurements. So, ang measurements na niya kay dili siya ma-accurate tungod sa noise. So, for example, kanang electrical noise from nearby equipment can influence readings. So, ang good transducer kay dapat designed na siya to minimize sensitivity to such unwanted signals while focusing on the desired output. So, for instance, shielding or signal conditioning can be used to filter out noise. So this ensures that the output remains accurate and usable. So in conclusion, when selecting transducer factors, kani nga factors i-ensure niya nga ang transducer not only provides precise measurements but also performs reliably in its intended application without being affected by its environment or external interference. Then now let's explore the classification of transducers. So kani nga classifications kay based ni siya on how they handle signals and their role in the measurement process. So first we have analog transducers. So it converts input-output signal, which is a continuous function of time, such as thermistor, strain gauge, LVDT, o thermocouple. So ang analog transducers daw, create siya og output signals that change continuously in response to the input. So think of it like kanang dimmer switch on a light, kanang light's brightness mo change na siya smoothly as you turn the dial, di ba? So ang practical example ani is kanang thermocouple. So ang kanang thermocouple device na siya para mo measure sa temperature. Then it works based on a principle called the Seebeck effect. So kaning nga principle, it states that when two different metals are joined together to form a circuit and there's a temperature between the two junctions, a small voltage is generated. So as you can see sa picture sa right, kaning thermocouple, na siya duha ka wires that are made of different metals. So diri wire type A ug wire type B. Let's say ang kanang wire type A is copper, then ang kanang B kay iron na siya. So at one end, kani nga wires kay they are joined together to form what we call the hot junction. So which is exposed to the temperature nga imong i-measure, like kanang kandila diha sa picture. Then the other end, called the cold junction, are kept at a known reference temperature, often room temperature na siya or gi-cool na siya artificially. So when there's a difference in temperature between anang hot and cold junctions, ang electrons sa metals move na siya differently due sa tungod sa temperature gradient. So mo create din ni siya small voltage, also called kanang electromotive force or EMF across the circuit. So the size of this voltage kay proportional siya sa temperature difference between the two junctions. So kaning thermocouple, analog transducer ni siya kay mo generate man siya og continuous voltage that directly corresponds to the temperature being measured. However, kani nga voltage kay gamay jud kini siya, usually naka millivolts. So it is sent to an amplifier or conditioning circuit for accurate temperature readings. So commonly used ni siya sa industrial applications like monitoring furnace or engine temperatures, where gibutang ni siya directly in hot environments. So their ability to handle extreme temperatures and generate a continuous signal makes them ideal for such tasks. So one advantage pud aning thermocouple kay ilang simplicity. So they don't require external power kay mo generate raman siya iyang kaugalingong voltage. However, they do require careful calibration kay ang relationship between sa voltage and temperature nakadepend siya sa type of metal nga gigamit. Then another device aning analog transducer kay kaning strain gauge. So kaning strain gauge kay gigamit ni siya or gamiton ni siya to measure force, pressure, or mechanical stress. So it works based on the principle ng electrical resistance anak nga material mo change siya kung ma-stretch or ma-compress. So imagine na kay thin metal wire. If you pull on it or imo siyang i-stretch ang wire, it becomes slightly longer and thinner. So kani nga change in shape, mutaas ang iyang electrical resistance. On the other hand, if you push on the wire or i-compress nimo siya, it becomes shorter and thicker, which decreases its resistance. So makita na nimo siya sa picture diya sa right. So kani siyang strain gauge, kana ganing orange nga rectangle, gamay kina siya. I-attach na siya dito sa object nga imuhang ganahan nimo i-measure, such as a beam or a machine part. So ang kaning object nga kung asa nimo siya gi-attach, if it is subjected to force, ang kaning strain gauge mo deforms ni siya along with it. Then this deformation changes the resistance in the strain gauge. Yeah, kani nga change is measured as an electrical signal, like a small change in voltage. So example ani niya kay kanang timbangan, digital weighing scale. Ang kaning strain gauges kay gibutang ni siya under sa weighing platform. So when you stand on the scale, your weight causes the strain gauges to stretch slightly. Then kani nga small deformation changes the resistance in the strain gauges, which the scale converts into a weight reading. So ninot ni siya nga example sa analog transducer no, kay it produces a continuous smooth change in resistance that corresponds to the force applied. However, because lagi ang kaning change in resistance is often very small, kay kinahanglan gid mag-add og circuits such as a Wheatstone bridge para ma-amplify ang signal niya for accurate measurement. Then we have in contrast, digital transducers kani converts input signal into the output signal in the form of pulses. So it gives discrete output. So ang kaning digital transducers can provide siya output in discrete steps. Much like flipping a light switch on or off. So ang ilang output kay it is in the form of pulses or digital codes which can be easily processed by computers or microcontrollers. So, ang nindot nga example niya kay kanay rotary encoder. So, ang kaning rotary encoder kay device ni siya used to measure rotational motion such as the angle, the speed, or direction of a rotating object. So, it works by converting rotational movement into a series of digital signals, essentially pulses. So, easier ni siya for digital systems to process. So, imagine na atay wheel or shaft nga ganahan nato i-measure. Ang kaning rotary encoder naka-attach ni siya dito sa wheel. Then, inside aning encoder, so anin niya kay nani siya disk with patterns of slots and lines. Then, a light source like an LED and a light sensor like a photodetector kay nakaposition ni siya on opposite sides of this disk. So, as the disk rotates, the slots periodically allow light to pass through, which the sensor dayon iyang ma-detect. So, every time a slot passes, the sensor generates an electrical pulse. Then, the encoder, iyanhing ipon kaning pulses para ma-determine niya kung how much the wheel has rotated. For example, ang kaning if ang disk kay na siya 100 slots, niya, ang encoder kay naka-detect siya 100 pulses during a full rotation. So, we know na ang wheel naka-complete na siya og 1 full turn. So, by counting pulses and knowing the time taken, the system can calculate the wheel speed. So, rotary encoders can also determine the direction of rotation using multiple sensors arranged in a way nga ma-differentiate niya ang clockwise and counterclockwise motion. So, ang digital nature aning rotary encoder means nga it produces discrete on-off signals or kanang pulses instead of a continuous signal like an analog transducer. So, this makes rotary encoders ideal for interfacing with digital systems like microcontrollers or computers. So, kaning rotary encoders na ni siya magamit usually or commonly used ni siya sa kanang mouse nato sa computer, kanang scrolling wheel. Nagamit na siya rotary encoder para ma-detect niya ang direction o amount of scrolling. Then, gamit din niya siya sa kanang mga industrial machines para ma-measure ang position and speed of robotic arms or kanang conveyor belts. Then ang advantage aning nakanindot aning rotary encoders kay highly reliable gid ni siya, kay immune man ni siya sa noise nga kuan kanang maka-affect sa analog signals. So maka-provide siya og exact repeatable readings, making them a perfect fit for modern digital systems. So gamit gid kay ni siya sa modern systems. Next, we have primary transducers. So when the input signal is directly sensed by the transducers and physical phenomenon is converted into the electrical form directly, then such a transducer is called the primary transducer. So kaning primary transducer kay device ni siya nga mo kanang it directly senses a physical quantity nga i-convert na niya into an electrical signal or mechanical movement without needing any intermediary stages. So example na niya kay kaning Bourdon's tube, kanang makita nimo sa picture, kanang kuan siya mo measure ni siya og pressure. So kaning Bourdon tube kay mo na siyang kanang curve nga hollow metal tube nga ma-deform na siya kung when measure is applied. So as the pressure increases, ang kanang tube mo straightens out na siya slightly, and this movement is directly proportional to the pressure being measured. So in this case, ang kaning Bourdon tube kay convert niya ang pressure into mechanical displacement. For example, kanang sa pressure gauges, kanay siya, the Bourdon tube bends in response to pressure changes, and this bending, kanang bend niya, mulihok nito ang kanang pointer para mahatag niya kung pila ang pressure. So, di ba, ang Bourdon tube convert niyang pressure into mechanical displacement. Para ma-convert ni siyang mechanical displacement into an electrical signal, para mas precise ang measurement, ari na dayon musod ang secondary transducers. So kaning secondary transducers kay it is a bit more complex kaysa sa primary transducer. So they work in two stages. Una, they take the mechanical displacement. So in this case kanang Bourdon tube, then i-convert na niya into an intermediate form such as kanang mechanical motion or change in position, and then convert din na niya ang katong intermediate form into an electrical signal. So ang example niya kay kanang LVDT or linear variable differential transformer. So kanang og inig bend sa Bourdon tube in response to pressure, ang kanang movement ana niya kay matransfer na siya ara sa core sa LVDT, kanang block diha na sa tunga. Ang kaning LVDT gi-design na siya para ma-measure ang movement by producing an electrical output that is proportional to the displacement of the core. So as the core moves kana mulihok, ma-alter din na niyang magnetic field inside sa LVDT. Then mo cause din na siya voltage signal. So this electrical signal ma-amplify din siya and processed to give a precise reading of the pressure. So by using the Bourdon tube as the primary transducer and the LVDT as the secondary transducer, we can convert the mechanical displacement caused by pressure into an electrical signal that can be measured accurately and displayed digitally. Then we have inverse transducers. So it is a device that converts an electrical quantity into a non-electrical quantity. So kaning inverse transducer, it works the opposite way of most typical transducers. So, di ba ang katong transducers nga akong na-cover ganiya kay ang kuha na to niya kay i-convert niya ang physical quantity like kanang temperature or pressure into an electrical signal. Ang kaning inverse transducer, it takes an electrical signal and converts it into a non-electrical output such as a mechanical movement, sound, or light. So, ang example niya kay kanang loudspeaker. So, ang kanang loudspeaker, i-convert niya ang electrical signal like kanang sound gikan sa imong phone or computer into sound waves nga atong madungog. So, ani ni siya pag-work. This is how it works. Ang electrical signal or katong sound nga gikan sa atong phone, mo travel na siya through a wire padong sa speaker. Then, ang sud ani sa speaker, nani siya gamay nga coil of wire o permanent nga magnet. Then, when the electrical signal reaches the coil, mo create din siya magnetic force that makes the coil move. So, ang kaning coil naka-attach ni siya to a diaphragm or kanang flexible cone which moves back and forth as the coil moves. Then, as the diaphragm moves, it pushes the air around it. So, mo create dayon siya og sound waves. Nya kaning sound waves mo na din itong madungog nga music or kanang speech gikan sa tong speaker. Then another example pud ani kay kanang actuators in robotics, kanang gamiton to make a robot move. So ang kanang robot controller mo send na siya og electrical signal or kanang current adto padong sa actuator. Then ang kanang actuator na siya yung motor sa sud nga mo receive na siya og electrical signal nya iyahan ng kanang i-convert or kanang ihimuong mechanical energy which is motion. Then ang kaning mechanical energy mo cause din ni siya part sa robot like kanang kamot baron sa robot or iyahang ligid para mulihok. Then the movement is controlled by the amount of electrical signal nga gisend padong sa actuator, making the robot's arm move up, down, or rotate depending sa iyahang task. So in this case, ang actuator kay mo take siya electrical signals niya i-convert niya into motion that moves the robot's parts. Then next is transduction principles. So ang kanang transducers mo operate na siya based on different transduction principles which describe how they convert one form of energy or physical quantity into another. So first we have resistive transducers. So kaning resistive transducers mo operate ni siya based on the principle that the resistance of a material ma change in response to physical changes like pressure, temperature, or strain. Example niya kay katong strain gauge which I discussed earlier. So resistive transducer to siya kay when force is applied ato sa strain gauge, di ba mo deform siya which causes its resistance to change. Then kaning resistance change kay ma-measure din ni siya and ma-convert into a force measurement. Then another example pod kay thermistor. So type of temperature sensor ni siya. So mo measure ni siya sa temperature. So if mo taas ganing temperature or mo decrease ang resistance sa thermistor, mo change pud na siya. So in this case, ang resistance change is directly proportional sa temperature. The next is capacitive transducers. So it works by measuring changes in capacitance. So which is the ability of a system to store an electrical charge. So ang capacitance, it depends on factors like the distance between two conductive plates, the area of the plates, and the material between them. Imagine two plates with an insulating material sa iyang tunga between them. So if the distance between the plates changes, the capacitance mo change pud siya. So in a capacitive transducer, kani nga change in capacitance kay magamit ni siya to measure things like distance or humidity. So example niya kay capacitive proximity sensor which detects the presence of an object without physical contact by measuring changes in capacitance. So, ang kaning capacitance, it is the ability of two conductive plates to store an electrical charge. Yang kaning nga charge kay na-influence ni siya by the material between the plates. So, ang kaning sensor, capacitive proximity sensor, nani siya duha ka plate nga mo create og electric field. So, when an object such as kanang kamot, metal, or plastic, mo enter na siya sa sensor's detection range, ma-alter din na siya ang capacitance between ato nga plates. So, this change kay ma-detect ni siya sa sensor, which then, mo send din siya signal para mo trigger og response. So, kaning capacitive proximity sensor kay mo na siya gamit sa kanang touchscreen sa tong phone, na if i-touch nimo ang screen, the capacitance at the point of contact ma-change siya kay ang imuhang kanang finger, which is a conductive material, i-alter man niya ang electric field. Then ang sensor mo detect siya og change and i-register din to niya ang katong touch, so allowing the device to respond accordingly. Next is inductive transducers. So, kaning inductive transducers, nigamit ni siya sa principle of inductance, which is the property of a coil or conductor to resist changes in current. So, this resistance to current change is influenced by the position of a ferromagnetic object, the distance between the coil and the object, or the object's properties. So, the sensor, nani siya coil nga mo create og magnetic field. So, kung ang metal object mo paduol siya or mo palayo atong coil, ang magnetic field mausab. So, kaning change in inductance is detected by the sensor, which can measure things like the position of the object. So, ang kaning inductive transducers kay gamit ni siya para ma-measure ang displacement and position. So, makita ninyo siya kanang sa manufacturing, kanang para ma-detect ang metal parts on an assembly line. For example, kanang ma-detect nila ang presence of metal objects as they move along a conveyor belt. So, ang sensor mo send na siya signal ato sa system, which can then trigger the next step such as sorting, counting, or packaging the items. So, reliable kini siya ang inductive transducers for detecting metal objects, especially in environments nga naay hugaw kanang dirt, dust, or harsh conditions, kay di na siya kinahanglan og physical contact with the object. Then last is voltage and current generating transducers. So kani siya kay special types ni siya of transducers nga it directly generate an electrical signal, either voltage or current, in response to a physical change. So kani nga transducers, they don't just modify an existing electrical property like resistance or capacitance. Instead, they generate an electrical output based on the input from the environment. So, kani nga direct conversion of a physical phenomenon into an electrical signal is useful in many applications, such as measuring pressure, vibration, temperature, and more. So, yung example niya kay kanang piezoelectric microphone. Kaning piezoelectric microphone kay transducer man siya. So, piezoelectric transducer na siya. So, it works based on the piezoelectric effect, which is a property of certain materials like kanang quartz or certain ceramics. So, when these materials are subjected to mechanical stress, kanang pressure, vibration, or mabend siya, mo-produce na siya electrical charge. So, murabag kanang if imo siyang i-squeeze or i-press ang piezoelectric material, ang atoms ato inside ato niya nga material mo shift to siya slightly, causing a build-up of electrical charges on the surface. So, mo create din na siya small voltage which can be measured. So, muna siya piezoelectric microphone. Ang kaning siya nga device kay ang sound waves, kaning microphone, ang sound waves kay mechanical vibrations mo na siya sa air. Mo igon din na niya dito ang piezoelectric crystal inside sa microphone. So, when the sound waves push against the crystal, they cause it to deform or vibrate. So, as the crystal deforms, mo generate din to siya small electrical voltage that corresponds to the sound wave. So, kaning electrical signal, ma-amplify din ni siya. Then, magamit na siya to create the audio output na mo nang kanang imong madungog sa speakers or kanang music sa imong kanang mag-record ka o audio recording sa imong phone. So, the louder the sound, the more the crystal deforms, and the greater the voltage generated.
Another classification of transducers is active transducers. Active transducers, are also known as self-generating transducers, is the transducer which develops their output in the form of electrical voltage or current without any auxiliary source. For you to visualize, it is like a special device that can measure something like temperature or pressure, but it doesn't need batteries or power outlets for it to work. This means it creates the electrical signal itself like a mini power plant without needing any help from external sources. Active transducers are further categorized into several classifications based on the energy process, and those are photovoltaic, thermoelectric, electromagnetic, piezoelectric, chemical, and others, which would be discussed later on. The last classification of transducers is passive transducer. Unlike active transducers which generate their own output, passive transducers requires external power source like a battery for it to work. They don't generate their own electrical signal, instead they modify an existing electrical signal based on the input they receive. This modification is usually a change in resistance, inductance, or capacitance. Passive transducers are also further classified into variable resistance, variable reactance, optoelectric, and Hall effect type. Variable resistance are transducers that change their electric resistance depending on the input signal. Examples include strain gauge, thermistor, potentiometer, and photoconductor or LDR. Meanwhile, variable reactance are transducers that change their inductance or capacitance in response to the input signal. Examples include inductive and capacitive. And optoelectric use light to sense and convert the input signal. Examples include photoemissive and photoconductive. And lastly, the half effect type use the Hall effect principle to measure magnetic fields or current. The Hall effect is the phenomenon where voltage difference appears across a conductor placed in a magnetic field. This voltage difference is proportional to the strength of the magnetic field or the current flowing through the conductor.
So, good day everyone. So, active transducer, so it is self-generating type of transducer. It's develop an electrical parameter which is proportional to quantity under measurement. It do not require any external power for their operation. So, active transducer is a device that directly converts a physical quantity, such as pressure, temperature, or motion, into an electrical signal without requiring any external power source. These transducers are also referred to as self-generating transducers because they produce their own electrical output based on the physical phenomena they are measuring. So, for example, thermocouple. It generates a voltage difference when two different metals are joined and exposed to a temperature gradient. So, photovoltaic transducer. It is the measurand is converted in the voltage generated when the junction between dissimilar material is illuminated. So, it is a operate on the photovoltaic effect, where light energy or photons striking the junction of two dissimilar materials. It generates a voltage or electrical energy. It has no external power source is required as the transducer converts light energy directly into electrical energy. Thermoelectric transducer converts temperature differences into electric voltage and vice versa. They utilize the thermoelectric effects, specifically the Seebeck effect, to generate an electrical output. The device comprises two different materials, metal 1 and metal 2, joined at two junctions. One junction is exposed to a higher temperature, which is hot side, and the other to a lower temperature, which is cold side. The temperature gradient creates a potential difference due to an unequal energy level of electrons in the two metals.
Piezoelectric transducer. A measurand is converted into change electrostatic charge or voltage generated by the crystal when mechanically stressed. Piezoelectric transducer convert mechanical stress into an electrical signal. This conversion is based on the piezoelectric effect, a property of certain crystalline materials. When these materials are subjected to mechanical stress, they generate an electric charge proportional to the applied stress. Conversely, applying an electric field causes them to deform. The image shows the common configurations. We have compression and bending. Compression, a piezoelectric crystal is compressed, resulting in a change in electrostatic charge or voltage, while in bending, a piezoelectric crystal is bent, again producing a change in electrostatic charge or voltage. In both cases, the magnitude of the generated charge or voltage is directly proportional to the applied mechanical stress. This makes them useful for measuring pressure, acceleration, force, and other mechanical quantities. Electromagnetic transducers. The measurand is converted into the electromotive force induced in a conductor by changing the magnetic flux in the absence of the excitation. Electromagnetic transducers operate on the principle of electromagnetic induction. They convert a measurand into an electromotive force. This conversion happens by changing the magnetic flux within a conductor without any external excitation needed to initiate the process. The diagram shows a conductor represented by a rectangular block is placed within a changing magnetic field. This changing magnetic field is typically generated by the measurand itself. As the magnetic flux linking the conductor changes, an EMF is induced across the conductor's terminals. According to Faraday's law of induction, this induced EMF is proportional to the rate of the change of magnetic flux. The induced EMF then measured, providing a signal directly related to the measurand.
Good afternoon. So I'll continue the another classification of transducers. So this transducer, unlike the active transducers, which is a self-generating type of transducers, passive transducer do not generate any electrical by themselves. Also, unlike active transducer that does not require external power for their operation. It passive transducer needs external power source. Yeah, and depends upon the changes in and it also depends upon the changes in electrical parameters. Passive transducers are also known as externally power driven transducers. So here are the types of passive transducers, which is the resistive transducers, inductive transducers, and capacitive transducers. Resistive transducers, it is an electrical device that is capable of measuring various physical quantities like temperature, pressure, vibration, force, etc. So, resistance transducers, these transducers change their electrical resistance in response to physical quantity such as displacement, strains, or temperature. So its principle is resistance changes due to the physical deformation of environmental changes. Example of it is the strain gauge, which measures the strains by the change in resistance of material when stretched or compressed. So also the RTD measures temperature by the resistance change of the metal like platinum. So mostly resistive transducers are transducer that depends on the resistance of the material. It has displacement or temperature. So another types of passive transducer is the inductive transducers. Inductive transducers measure is converted into the change in the self-inductance of the single coil. So inductive transducers detect changes in inductance caused by the movement of a ferromagnetic core, variation in coil geometry, or changes in magnetic permeability. Its principle is inductance changes with variation in flux leakage. So the example of it is the linear variable differential transformer, which measures linear displacement by detecting the change in mutual inductance between coils. Also the eddy current sensor, which measures displacement or proximity by detecting eddy current effects. Also, another example of the passive transducers is the capacitive transducers. The measurand is converted into change in capacitance. So, the capacitive transducers, these transducers work based on the changes in capacitance caused by the variation in the distance between capacitor plates, the area of overlap, or the dielectric constant. Its principle is capacitance changes with displacement, pressure, or dielectric changes. Example of this is the displacement sensor, which measures small changes in distance between capacitor plates. Also, the pressure sensor used diaphragm deflection to alter capacitance. So that are some examples of some types of passive transducers, and that will be all for thank you. Bye.